Okay. And as you can see, I fit some code already because I didn't want to like bug you with all these complexities and all of that. I know you guys may not be very cool with programming language so deep. So I just wrote this code down, and then I'm going to explain what it actually does. But I've already explained what it does earlier on, but I'll just show you the core implementation. So, like we said earlier on, when we're tokenizing, we create a vocabulary of all the words in the data set, and we use it to to correlate or match with each sentence in of each data point. In this case, that is the messages. So that's basically what we were doing. And then this is now the core implementation. So we import numpy, and we assign a tourist, and then we loop through each queen vocab, and we do some logic here. And we say if token is not in single tokens, and we add the single tokens, and then we now loop, and now if this token is in this single token we added, and it's not in the unique token, then we add it. This what we're trying to do here is we're trying to get a unique token, so the tokens are not repeated. For the token here is the corpus in each word in the vocabulary. So just bear with me. I use tokens to define because it was more intuitive to use tokens. So it's going to create a unique corpus for each data point. And then once we create that, then we now have to um, we now have to create a pandas data frame. That's we're creating our own data set. Remember when we um, put this CSV file, we use our pandas to like read it to a pandas object. Now we're going to create our own data frame like that, because this returns a data frame. This data returns a data frame. So we're going to create our own data frame, like it's a new data set for us because it will be our training data. So we pass in the values, that is where you could start from, where you should end, and the columns are unique tokens. And then to now make it um is unique now. So now to now like categorize each match each what do you call it, each corpus together. We now loop through and pass in the vocab, asking the vocab, and then we say if token is in item, if token is in for token in item, loop to each item in the token, and if it's in unique tokens, then we increment. So now we're kind of, like I said, we're kind of creating a data set, but this time around we could have a data set that will have 2, 4, 5, 6 instead of 0 and ones, like that one hot encoding system. One encoding system just does zeros and ones. If it's not there, it is zero. If it's there, it's one. But this now is going to like populate it based on the number of fields. So example, if we have apple is a corpus or a token, and it appears in 4 data points. In each of them there will be one, 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 and I will see those data points also. Purple and guava also appears as a corpus in in the sentence. There also be two, one, 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 one. So that's basically, so let us run this, and hopefully we have no errors. It's taking some time. Okay, So let's see our data sets, our data frame. So as you can see entry. You can see entry for the second data point. We say entry appear twice in the sentence. You can see, and in we can see that it's not only ones on zeros. It's just it also includes one, twos, and higher integers, and the ones it doesn't have. For example, all these are the vocabularies. So all these are the words or tokens or couples in the vocabularies. So let's say for the first the data point, which is this zero. Now in is there, there is there, ob is there, as you can see. So others are not there. This is the only one that belongs to there. So for this FA, it is two here. It appears two in this sentence. N3 appears twice. Two appears thrice. As you can see, this is just the arrangement of it. Yeah, but there's one other thing we have to do in our processing words. That's what they call stop words in NLP. Stop words are words that overfit, I would say, that cause the model to overfit because they don't pass any type of information, any type of new information or serious information for the machine learning model. So they are just continuous. For example, some popular words like if, L, I, in, and all of that. Because we are doing a sentiment analysis, so all these will not be important because they are so common words, and there will be so much. There will be so much um in 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 our data set, and they will just be blocking our machine learning model from learning anything useful. So so let me show what I mean. For example, um let us check. First of all, let us create a new text. Let's say removing stop words. um, Showing you the stop words, you understand what I mean by stop words. So let us put our count. Okay. Now we can see this in. You can see that it has 883 um appearances in our data set, and U has 1006. You can see all these common stop words. I would say common data. They are so much, and they don't as if they add anything, um any information to the data, because we're analyzing the sentiment, just the verbs that what we care about, the action words, like something like calculation, flip, and all of acted. So all these are called stop words. So we need to take them off. Take them off. So our machine learning model don't get overfit with some stuff that they're not important, that are just full everywhere, that will block it from learning anything from our data. So the way we're going to remove it, we're going to remove it by put counts. We slice, do some list slicing of list, and put word count.